Hello, everyone, and a happy Friday. It was such a pleasure to get to meet so many of you this past week, and I hope you've been having a good first week of the semester and that all of your classes have been going well. The purpose of this video is to do what I like to call the studio review. So every week on Wednesday, you'll be asked to do this in-class studio assignment with your peers. But I also like to make sure to post a review video where I go through the solution and talk about it. Sometimes people don't finish, sometimes people are absent for whatever reason. So I just like to kind of provide, my own take on the studios and make sure that everybody has all the information they need, regardless of how their week has been going. So this first studio is, more of a practice studio. It doesn't count for credit, but still a lot happening, and actually it was a pretty busy day for me in the lab on Wednesday, fixing a lot of technical problems and stuff. I hope that all of those issues have been resolved for you, but if you are still having problems getting everything set up, please let us know as soon as possible so that we can get things up and running so that you're ready to start working on the course materials. Starting next week, things are going to count for real. It's actually going to not be practice anymore. So I want to make sure everybody's up and running and ready to participate in the course. So let's go ahead and start by going through Studio Zero. And I'm not going to do this every week, but since we're all kind of new to this, I actually want to talk about the process of getting the repository into VS Code. This is something that you're going to be getting a lot of practice doing throughout the semester, because every time that there's a new assignment or a new studio, we're going to ask you to do this part of it, where you click on a link. I actually already did this part of it before class, where you click on a link and you generate one of these, which is called a repository. This contains all of the code for this particular assignment, Studio Zero. There'll be another one of these for Studio 1 when you come into class next time on Wednesday. And if you're working on the assignments, right, we'll talk about assignment 0 a little bit towards the end of the video. There'll be another repository for this. So every time we start something new, we have to do what's called a clone. We have to essentially take it from the website, right, and make a copy of it on our computer that we're able to work with. And the way that we do this is by grabbing this URL that's right here, copying it, and then coming over to VS Code, you can see that, I actually have the exercises open here, right? So here's my exercises. I want to get the studio in here though. So I'm going to go ahead and, click on this little link that will let me to clone the Git repository, paste in the URL from before, right? And then now it's asking me where on my computer I want to put it. You can see that right here, I've already made a folder for this class to use to store things. I really highly encourage you to do the same. If we look in this folder, we can actually already see that the exercises, that's where the exercises live. That's where I'm going to put my studio and all of my studios and all of my assignments. So by the end of the semester, there'll be lots of folders in here, right? One for each studio, one for each assignment and stuff. So I'll go ahead and click select this repository destination. It's now going to ask me if I want to open it. So if I open it, it's going to replace what is currently in Visual Studio Code. So my exercises are going to shift away, and now we'll see that instead I see the studio. But before I actually hop into the studio, I just want to make up another point, right? What if later on you're like, well, the studio's over. I want to go back and revisit the exercises again and start working on the exercises. Well, in order to do that, you actually don't have to go through the clone process all over again, right? You only have to do that once at the very beginning of each assignment. Afterwards, it's already on your computer. You just have to open it again. So the best way I found to do that is to tell it to open a folder. And then here you can see, this is my folder for this class. You can see, if I want to open the exercises again, then I can simply select the exercises folder and open it. And now here I am back to the practice problems, the practice work for all of the for the first 3 course modules, right? So that's how we're going to switch back and forth between our projects. Again, this is all new to, I would expect, most, if not all of you. So I totally understand if this feels strange or different or maybe even a little intimidating, a little challenging. All totally valid feelings to have at this stage of your coding journey. The learning curve is a little bit steep right now, but I promise you, again, with more practice, doing it a few more times, it will start to make a bit more sense and feel a bit more natural. So with all of that out of the way, let's go ahead and hop into the studio itself, starting with the very first problem. They want us to open up the lunch receipt. So let's go ahead and find the lunch receipt. And we're just going to kind of examine this code a little bit, see what's going on. Up here at the front, I see I'm creating some variables, right? With some various information associated with them. The burritos price is $7.50. The drink price is $1.25. That's how I'm interpreting this. And the reason I'm able to interpret it that way is because these variable names are descriptive, right? They tell me that these are clearly prices of food that I apparently have bought for lunch, right? Next, we compute the subtotal. We have the tax rate, and then we compute how much total tax there is. And then we go ahead and we print out everything, right? We print out the grand total for all of our lunch. So we can run this program, and I'll go ahead and do that now by clicking the little triangle up here in the top right corner. And after we run it, it says, all right, our total was $12.76. There is a way to have it, ignore everything after the first couple decimal places if we want to, but that's not really important for what we're doing right now. I think the bigger question that I have is, well, is this reasonable? Is this actually an accurate response? It seems like it's kind of in the right ballpark, right? If I do some, mental arithmetic up here, I see there's $10 worth, and then here's another $2.25 that's on top of that. So, this definitely seems like it's in the right ballpark when you add in the taxes and things like that. But is it actually correct? I mean, if it was off by a few pennies, would I know? Would it be a big deal? Maybe not for one order, but certainly if I was off by a few cents on every order, that could become a very big deal if I'm running a business selling lots of orders. So, how do we actually know that this is correct without sitting down with a calculator and verifying all of this ourselves? Well, one of the best tools that I know of to verify this is called the debugger. And I am always going to be using the debugger to kind of help analyze things. As the semester goes on, I'm going to introduce more and more things that you can do with this tool. But for now, we're going to start by following what the instructions want us to do, which is to add a breakpoint. And I'll just go ahead and add the breakpoint right up at the very beginning part of the file, right about here. By clicking on that red circle, you can see that breakpoint is now on. And to run this in debug mode, we're actually not going to click the triangle. We're going to click the little arrow next to it and select debug. In fact, actually, I'll show you. If you click run, it won't start the debugger. It'll just run the whole program from start to finish. But if I select this and I click debug instead, it won't run it through start to finish. It's actually going to pause. It's going to break, is the official term, at this line. And we now see that we have some new buttons up here at the top. These are what we're going to use to control the debugger. Right now, there's only a couple that I'm really interested in talking to you about. This one right here is called the Step Over button, and it's going to allow us to proceed through our program one line at a time. And the nice thing about doing that is that as I proceed through the program, you'll start to see the variables over here on the left-hand side. And as I compute arithmetic and such, I can verify that that arithmetic's all been computed and appears to be correct. So as I continue to step over, we'll see each of these variables gets declared. That's something that we talked about in class. A declaration is a type followed by a name. We also initialize it by setting it equal to some value. That's also called a variable assignment. So these are all very common operations that we're going to be doing in all of our programs this semester. And now we finally get down to the math, right? So let's go ahead and see if we can verify that this is actually computing our lunch bill correctly. If we step over one more time, we see that the subtotal is computed as $12.25. I believe that is correct. I believe I did that math in my head. Here's where things get a little bit trickier to compute. We're going to compute the tax amount, which is apparently going to come out to 51 cents at the given tax rate. So that does appear to be computed properly. And now to get the final amount, we're going to add those two together, and our $12.25 plus 51 cents does in fact get us to $12.76. So this program, as far as I can tell, appears to be working just fine. It appears to be doing A-OK. The debugger is good for situations when that's not the case. In fact, that's kind of where it gets its name from. The debugger is oftentimes used to help us find where the problems are in our code. but it's also a really good tool just to kind of go through and check our understanding, make sure that we understand exactly what's happening in a program step by step. Let's switch gears a little bit and move on to the next problem, which is the mileage report. So I'm going to go back to, and so this program actually is still running. It actually hasn't finished yet. You can tell that because it hasn't even printed. I don't actually care if it finishes or not. I want it to stop, which this red square right here will allow me to stop it. And then to get back to the files, we're going to click the Explorer button up here on the top left corner. And now we can go ahead and move on to Mileage Report, which is our next program. And this one, if just by looking at the variables and kind of thinking about it, we can see, all right, it looks like we're driving a car around. So here's 3 trips and the miles that we drove, the total miles that were driven. I see the miles per gallon of the car that we're driving, the total gallons of gas that we're expecting to use, the price per gallon for a gallon of gas, and then the total price is getting computed. So all these, again, I can deduce just from having good variable names in this code. And then finally, we print out the total price that was spent on gas. So let's go ahead and run this one. And if we run this, we see that, okay, at $3 per gallon, it says that we're spending $93,406.25 on gas. That seems a bit high, if I'm being honest with you. My gas bill has not been quite that high. I mean, these aren't the shortest trips in the world, but still pretty high even for a 900-mile trip. So in this program, there's a mistake. Something is not being done properly. We need to figure out where that problem is. And actually, this is a small enough program to where you could argue that you don't actually need the debugger. You don't actually need to work through step by step and figure out where the problem is. I might actually agree with you, right? Like, you're not going to need to use this tool every single time there's a problem. But if it's a tricky problem, if you're having a really difficult time with it, then it's another tool that you'll have to help you resolve these kinds of problems. So if you aren't able to figure it out by inspection, the debugger would be, I think, a next good step, and that's often what I recommend to students when they're having problems on a homework assignment or something like that. So I want to get practice using the debugger. I'm going to do similarly to what I did last time and set a breakpoint right here on line number 6, and I'm going to come over and I'm going to tell it to start debugging again. And I'm going to keep an eye on my variables as I go through and try to identify where things start to go off the rails and seem like we're not doing things properly. So these first 3 are just how far we're driving the car. I don't think there's really anything wrong with that. We're now going to compute the total miles, which should just be the sum, and you can actually compute that one in your head, and that number looks right. Now we're going to say that the miles per gallon is getting 24.5 miles per gallon, and so we're now going to compute the total number of gallons that we expect to use for driving this amount. And I think we may have found a potential issue, because if I look at the total gallons, it's telling me that I used 30,625 gallons of gas. That is a lot of gas, considering that my gas tank is, maybe 15 gallons total? So that's a lot of fill-ups. We have found the problem. So the problem has to do with how this total gallons is getting computed. So let's take a look at that line. I'm going to stop the debugger here, right? The total miles is 1,200 something. Miles per gallon is 24.5. But we're using multiplication here. I think actually, since this is miles per gallon and not gallons per mile, we're actually computing this improperly. This should be division, not multiplication. We could run this through the debugger again, or we could just run it normally and see how that affects the outcome. Let's run it through the debugger and see what the total number of gallons looks like now, and see if it's a more reasonable sounding value. Okay, so now we're going to get the total gallons as 51. Oh yes, that is much more within what sounds like normal gas usage for a car, right? So now there's our price per gallon, and the total amount we spent is a whopping $155.61. That seems very much entirely reasonable. So there is another great example of how a small mistake, just using multiplication instead of division, can lead to a very big difference in outcomes. And the computer does not know what our intent is, right? The computer does not know or care what we're actually trying to do. It's just faithfully running exactly what has been written, the instructions that it has been given. So if it's given an incorrect instruction, it has no idea. It's just doing what it's been told. It's on us to determine which lines of code are incorrect and to fix them. That's actually, I would argue, one of the biggest parts of programming. So let's go ahead and move on. I believe there's a couple more exercises left to go here. Burrito budget. All right. So here we're going to switch over to the burrito budget program. And just like before, we see some variables that get declared up here at the top with, it looks like, how many burritos we're eating in a week. This was written before the Qdoba was open on campus, believe it or not. But now that the Qdoba is open on campus, I feel like these numbers may go up a bit more. We'll see how things go. It tries to add up how many total burritos we've eaten. It tries to figure out how many burritos we've eaten in a week, and then compute how much we're spending on average per week on burritos. What's our burrito budget, as the program is named. If I run this, we'll go ahead and see that. Okay, it's telling me I spend $52.5 per week on burritos. And, it's a little harder to do this math in your head, right? This is more maybe kind of paper and pencil area. But just kind of going based off of feel, that doesn't seem extremely unreasonable. That seems like it's well within, kind of the expected range. But it's a similar question. What if it's off just by a little bit? What if it's only off by like a little bit? Let's run through this code with the debugger and verify that things are actually being computed correctly. I'm going to set my breakpoints at the very first line of the program here on line 6 and start the debugger and walk through step by step. The first few steps are just saying how much we've been eating, so there's really nothing here that we can argue with. This is just trying to sum everything up, and this is math you can still do in your head. This should be 31, right? Yeah, so there's 31. That's good. This one we can also kind of do in our head, right? 31 divided by 4, so let's see, it's going to be like 7 point something, correct? And, well, wait a second. My radar is already kind of going off a little bit. I would expect this to be not 7, because 7 times 4 is 28. I would expect it to be 7.75. So this average weekly burritos number is off. It's not off by a lot, but it is off. It's not as correct. It's not as accurate as it could be. So the next question then is, well, like, why? Because everything up until that point did seem to make logical sense, right? It did seem to be, something that we could follow. The arithmetic in this case doesn't seem like it's all that wrong, unlike the prior example when we were using the completely wrong operation, using multiplication instead of division. The issue here brings us squarely into the realm of computer science, right? Out of math and more into computer science. And specifically, it has to do with the topic that we are discussing this week, which is data types. The operations that get performed on the computer depend very much on the types of data that are being used. And here you can see that we're using a lot of ints. Int, 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 int. So it might seem like a subtle distinction, right? But if I have a double and I add it to another double, that's going to give me a double in response, which kind of makes sense, right? I want to keep the decimal places. If I have an integer and I add it to another integer, that's going to give me an integer back, right? My result will be an integer. That all makes sense. In fact, you can see here that when we add all of these integers together, we store the result in an integer variable, which makes sense, right? That should be an integer. But then let's take a look at this expression right here. This thing on the left-hand side is an integer. This thing on the right-hand side is actually also an integer. The number 4 is an integer. So an integer divided by an integer is going to give me an integer. And you might be saying, well, wait a second. You actually said over here that it should be a double, which is true. However, consider that assignment statements are evaluated more from right to left. So the right-hand side of the equal sign happens first. This operation is going to be computed as an integer. It is then going to take that integer value and store it in the double, which is why we saw 7.000 there. Consider too why it was 7 and not 8. It does not round when this happens, right? So 31 divided by 4, the example that we're doing here, is not going to be 7.75 rounded up to 8. Instead, when we divide using integers, it just chops the decimal off. It always rounds down, I guess is another way of thinking about it. So even if the answer was 7.999999, if it's an integer, that 0.999 gets chopped off and it becomes 7. In this case, it was 7.75. We chop off the 0.75 and it just becomes 7. So that's what we were seeing. That is the mistake that exists in this program. But how do we fix it? How do we make it so that that doesn't happen and we get proper values? There's a few different ways that we can actually do it. We need to change the type of something that appears either on the left-hand side of this division or the right-hand side of this division. Where do we say what the type of this variable is? We actually say that right here. So if I come up and make this not an int but a double, that actually is going to solve our problem, because this is now a double divided by an int. That will not be an int, right? Because then we risk losing any information from the double. That's going to be a double. So that's another important thing to consider. Anytime if I'm mixing types, right, I'm always going to pick the type which is able to convey the most information. So a double combined with an int is always going to be a double, because doubles have the ability to convey more information than ints do, just by the nature of having that decimal value. All right, so back to this. Let's run this again. It was 52.5 before. Let's see what it is now that we've attempted to fix this. It now tells me that, oops, I started it in debug mode. I didn't mean to do that. I meant to just run it normally. So let me go ahead and stop this actually. It's now telling me that it's $58.13 per week on burritos. So that's actually not a non-trivial amount, right? That it went up by about $5 or so, $5.50. Almost $6, something like that. So, even though that first number did seem kind of reasonable, past the plausibility test, it was actually still wrong. There was a computation, a very subtle one, not anything to do with arithmetic, but just a subtle computation error that was causing our results to be wrong, and we could use the debugger to figure that out. Just to give you, another solution to this problem, if we switch this back to an integer, we could also make the right-hand side of the division become a double just by adding a decimal point, right? So this is now a double, not an integer. And if I run this code, I actually get the same exact answer as I did with the prior version, $58.13. So more than one way to fix this problem. That's, going to happen all semester long, and it's actually one of the things that I like the most about computer science. Yeah. All right. So then, the last part of this was one that a lot of people had trouble with, and this is, I want to make it very clear that the problems that were happening were not you all's fault at all. It was more my fault. We switched to VS Code just this semester, so we've been using a different version, a different tool to do the coding part of this class prior to this semester. And so this is one of the growing pains that we discovered as we were going through things. We tested as much as we could. I thought that everything was up and working. Unfortunately, this part of it was not working. So I am sorry about that, and I'm sorry that part of the first, the very first studio you did was not functioning the way it was intended. However, I do want to let you know that this isn't going to be a problem long-term in the class. If you have this issue, it's not going to stop you from doing well on other assignments. So not something that you need to worry about, not something that's going to cause you long-term issues. It is something that I think is worthy of being fixed at some point, which I am going to keep working on and hopefully make an announcement about sometime in the future. But for the purposes of this video, I actually just kind of wanted to show you how this works properly so that you can see and understand this concept even if you weren't able to actually execute it yourself in the studio the other day. So the main thing that I want to show you is how we can kind of do the reverse of what we did at the beginning. So at the beginning of the studio, we took code that was on the internet, on GitHub, and we put it onto our computer. But we've changed some things since then, right? We've fixed some issues and made some things better than when they originally started. And I want to take those changes and I want to put them back onto GitHub. I want to put them back onto the internet so that, if I'm working on a project with other people, they can see those changes and benefit from those changes, right? That's working on a team. That's what it's all about. So in order to do that, we're going to switch over to this tab here in Visual Studio Code. This is called Source Control. It's going to show us that there are two files that have been changed, the burrito budget and the mileage report. We looked at some other files, but these are the only two that I actually made any changes to, that I actually tweaked the code of. So we're going to go ahead and click. I'm not going to click the big blue button. It's very tempting, but instead I'm going to click here and select commit and push. So we need to do both things in order to send our code back to GitHub. So once I click this button, it's going to ask me to type in a message. You actually could have also typed it in here if you wanted to, but if you forget to do that, it'll ask you to do it now, and I'll type in Studio 0 is done, and then save the file and exit it out. And then once that's done, it will go ahead and push those files back up to github.com. And we can actually verify this by then going back to our browser and refreshing the page with our code to see that, oh, that's the message that I just wrote. Studio 0 is done, and the time is right now. And actually, even further, if we go in here and we take a look at mileage report, for example, we can see that this used to be a multiplication sign, but now it's a division sign. I fixed it, right? I fixed that mistake. I changed it. So this is a way that we can take code from our computer and send it back to the internet so that we can share it with other people. All right. I believe that covers everything that I wanted to chat to you about regarding the studio. Just one more thing regarding the assignment before I end this video, right? I want to remind you all that while we ask you to practice as much as possible, and I think completing this assignment is a very good and encouraged idea, we do not grade the assignments. So you will not be graded on your work on this assignment, but I think it's still good practice for you, something to still, take a look at and see if you can do. It's going to ask you to make a repository by clicking this link, just like you did on the studio and just like you did for the exercises. So that'll be another chance for you to practice loading another project into VS Code, right? But the other thing I want to point your attention to is that as you're working on the assignments, right? On Canvas, we have rubrics posted. So if I come down here to assignment 0 and take a look at it, down here at the bottom, we actually have rubrics posted. So these are from past semesters, but and this one is again just sort of a practice assignment. This is not really the best example of the kinds of rubrics that you'll see on other assignments necessarily. A lot of times they'll ask you questions about the code itself, and not so much about the actual class. But you can use this to kind of see how you're doing on these assignments. And if you want to, you want to come in and have me or one of the TAs, walk you through the rubric. You're not going to get a grade for it anymore, right? But you can at least have someone walk you through the rubric and get an honest answer about how your code is and how you're doing on these assignments. So I just want to make sure you're all aware of that. You're all aware that these exist, and that is another resource for you. Again, we're just trying to provide you as many opportunities to practice and learn as possible. I see that as my primary role as an educator, is to expose you all to as many practice opportunities as I possibly can. Alrighty, that's going to do it for the first studio review for the semester, but many more to come. I hope you all have a great rest of your day and a wonderful weekend. No class on Monday because of the Labor Day holiday, but I will see you all back in the labs for Studio 1 on Wednesday.